And you know, we did drive purely electric to get here.
Yes.
Excellent.
We actually drove the second Tesla ever made to get here.
And it was a snazzy looking vehicle. We found each other in the parking garage. Whoa. Would you like to say just a little bit about yourselves before we get into questions? I think that would be nice.
Sure.
Yeah.
Sure. So computer science, you know, engineering background. I went to that other school in the Bay Area, you know, UC Berkeley, and worked in the Middle East for years in Saudi Arabia, which if you want to see what oil does to a local economy and where our treasure ends up going, spending 6 years in Saudi Arabia is quite illuminating. And then I came back here to Silicon Valley, did a bunch of stuff, found Martin. We ended up starting a company in digital media, sold that, which was great because we sold it in 2000, which for those of you who have a historical bent, that was a very good time to be selling such companies. And then in 2003, we started Tesla Motors.
Yeah, I'm also an engineer, not from either of those schools. I'm a master's degree in electrical engineering from Illinois, and worked in various high-tech companies around Silicon Valley. Started 3 companies, Tesla being my third. Actually 4 now. I'm starting one at the moment. Somewhere along the way, I started thinking that maybe this global warming thing was not a hoax, and that maybe the wars we were having in the Middle East were at least somehow involved in oil, and decided that we needed to do something different. I did not start off as an electric car enthusiast. My interest was just simply using less energy. So I spent some time doing a real careful well-to-well energy analysis for every kind of technology I could find, and built a spreadsheet that calculated the actual energy footprint and carbon footprint of every pathway I could find. Along the way, began trying to persuade this guy to do this insane thing of starting a car company with me.
Insane.
And it was, to both of our surprise, that the electric car pathway was not just better than the other choices that were out there, that included hydrogen and every form of petroleum and natural gas and so on. But it wasn't just better, it was dramatically better. It was so much better that it was stunning to us that nobody else was doing it. So, yeah.
So you've answered part of the founder story. I wondered how you found each other. Is there more to the story? Where did you find each other?
I think we met, so...
We met at NCD. Yeah, NCD.
Yeah, so his college roommate was a colleague of mine at a company I worked at, and we met socially at first.
Right.
And I think that, I mean, I guess we enjoyed having these long conversations about technical things, and discovered that our thinking was compatible.
Right. And we played Magic.
Yeah.
It was a card game.
It's true.
Students, you have sent questions, and they have gotten to see the questions. But if anybody wants to ask real time, that or anything new, and this includes everybody in the room, you know, jump in there. Otherwise, I'm going to monopolize them, and you don't want me to do that. So is there a most burning question to start with from you guys before we get into some that we know of? Yes?
I'm curious if you could give like a quick timeline of Tesla. You said 2003, and I think the first Roadster came out a few years after that.
A few years, yeah. Yeah, it turns out making cars is really hard. Yeah.
So I mean, from my perspective, the timeline is something like this. Around 2000, I got divorced. and like any, you know, macho American dude, I decided the thing to do at that point was to go buy a sports car so I could feel better. But I couldn't bring myself to buy a car that got 18 miles to the gallon in the end. I just couldn't do it. And so I started looking for an alternative for myself. And that's when I started thinking about energy and thinking about what it really meant to be a more efficient car. And starting in maybe about 2001, 2002, I started thinking hard about how would you go about this, and trying to persuade him. I guess there's a tie into Stanford on this along the way, that at first I thought I would go to law school because I was very interested in the transition of digital content as it gets separated from printed books.
It became my personal mission to save the world from Martin as a lawyer.
Yep, exactly. Yeah. So this is how I talked him into doing this insane thing of starting a car company. So 2003, we actually incorporated the company. I had come up with the idea for the name of the company, and he immediately liked it, even before he really agreed that we would do cars.
Yeah, but you know, we did mess up in that we incorporated on July 1st of
Yes.
2003. And then we discovered, and it was literally, we were working with a lawyer, and we went, and it was like, you know, the 4th of July holiday is coming up. Can we just get this done before the 4th of July? We then discovered that Tesla's birthday is, I think, July 12th or 10th. And if we had just waited, we would have, I mean, if we had thought about it, but it never occurred to me to check the birthday. So.
But it was, I mean, I remember that I've been saying, we should start a car company. He's like, you're nuts. We really should do this. This is an opportunity here. You're nuts. And I went on a date with my girlfriend and said, and had this idea for this name, Tesla Motors. And I came to Mark and I said, hey, Mark, what do you think of the name Tesla Motors? And he doesn't say anything. He taps for a few minutes on his laptop and says, oh, we own the domain name. And that was when I knew I had him.
Yeah.
So we then began working hard on how you would go about building an electric car. And we realized that we did not have the ability between us to actually build a whole car from scratch. So we started looking for a partner, somebody who was an automotive company, knew how to build cars already. And we studied kind of everybody in the world that would be potential, and came to the conclusion that Lotus was probably our best match. Mm-hmm. So we went to the LA Auto Show and basically forced ourselves upon the very polite English people at the Lotus booth until they would come and listen to us and invite us to England and make a pitch. So we, go ahead.
Yeah. So we go down to the LA Auto Show, and this is very startling. It's just the two of us. So we've been researching, and we figured that they're a good impedance match. There's a couple of other possibilities, but they're the best for actually making the car part. We can make it go. We just can't. It's the car part that had me worried the most.
Chassis and suspensions and,
and we're not
seats and seat belts and
we're
airbags
not
and
any
safety,
value
crash
to that.
safety.
I mean, you know, people have been doing that for 100 years. They know how to make that part, right? So we go to the LA Auto Show, and there's there are these defenses to prevent you from getting into the booths. There's little ropes and everything, and we literally just kept pestering them until finally there's these secret little rooms behind every booth, and they let us into the secret little room. And the very polite British man said, "Oh yes, startup car company, crazy Californians, yes. You come to England and we'll talk about it." And that was a great way of putting a little. We said, "Okay, great, we'll do that."
Yeah. So we actually agreed, and so we planned a trip immediately to go to England.
Yeah. Much to their surprise.
So we had a pretty good idea of the technology. I guess another key piece was we understood that electric cars live and die by their batteries. We knew that from the beginning. And in our prior company, we had learned about what was then fairly new lithium-ion batteries. As we transitioned from nickel metal hydride batteries to lithium-ion batteries, we realized that these were much, much better. And so, sort of before we really got serious about it, the question we asked ourselves is, could you take that battery system that we built into a handheld piece of electronics and scale it up all the way to the size of a car? So we did a bunch of math and a bunch of doodles on napkins to see if the design would work, and we concluded, yes, it would. It wouldn't be easy, but it was feasible. And it was radically, radically better than any other electric car batteries. But I guess another key thing we did is we were looking at, you asked me, how come every other electric car failed in? And we
did a deep dive on that.
We did a deep dive. We looked at the basically marketing brochures and so forth from every electric car company that had ever been around since at least 1950. And what we saw was every one of those cars, they were trying to make a car that would be immediately affordable to everybody. Mm-hmm. So it had to be a low-end car that everybody could afford, which is, it's unreasonable to expect any new technology, especially competing in a very mature industry, to compete on price. It's not reasonable. I mean, when flat-screen TVs came out, they weren't cheap. They were really expensive. And so we said, okay, it's not possible for us to compete on price, not just because of our new technology, but because every car part we want to buy, tires and paint and seats and everything, we're going to pay double what Honda or Ford or somebody pays. So we thought about it and said, if we're not going to compete on price, where can the electric drivetrain compete in a way that's actually better than the gasoline cars? And to us, once you understand motors, it's performance. Mm-hmm. So we decided from the beginning to build our first car to be something that was completely different than what everybody expected an electric car to be. Now, I don't know if you guys all remember how we thought about electric cars in the year, let's say, 2002. There's two things everybody in the world knew about electric cars in 2002. One, they're dead, and two, they suck. That's what everybody knew.
Well, in golf carts.
And golf carts.
They always looked like clown cars or golf carts in some way.
So if you look at the original Tesla Roadster, it completely shatters that image of an electric car permanently. Everybody in the world realized that the really fast cars out there, in fact, are the electric cars. Yeah. So this
How
was
many of you have actually gotten to ride in a Tesla?
Ah,
How many of you have ever seen the original Tesla Roadster, the little two-seater car?
Oh, yeah, actually.
Good.
So you've answered much of this first question, but I bet there's some little more to mine. And it's that many startups need to pivot and pivot and pivot again to find just the right fit, that's really going to be taken up. And your huge insight was, let's start at the top of the market and we'll make our impact on the world by starting there and then moving down. But I seem to recall you had to pivot a time or two as you launched. And how did you know when you got it right? And what is the learning that you could teach, our students as they do their own startups perhaps in the future?
well, we may have a disagreement on what that means exactly, but the problem is that in sort of new startups in the digital world, you can spend a bunch of time and create a product, and it can be a disaster, and you can change it, you can pivot along the way really easily. If you're building something that's physical, big physical thing, like a car, it doesn't get much bigger, you can't just say, toasters. We really need to we're going to have to pivot and make toasters.
Yes.
It doesn't work quite so
No,
well.
I completely agree with you.
Yeah.
I think
So
that
you have to freeze a lot of
we
it.
didn't
Pieces of the puzzle
yes.
get changed.
As an example,
But-
our original sales strategy for the car was wrong, and
Totally wrong.
and we originally thought we would sell through automotive dealerships as everybody else did, and the moment of change came when we came to understand how automotive franchise laws work. They basically make it, if you ever sell a franchise for an automotive dealership in any state, you can never sell the cars directly to customers ever again. And the dealerships cannot be shut down.
There's a law preventing you from
There's
Yes,
law.
there's
It's
law.
actually legal. It's a law.
it's a
Like,
monopoly.
The sheriffs will come and
Yes.
stop it.
Yes.
Fascinating.
And so, and the reason that the buying and servicing experience is so bad for most cars is because those dealerships have a virtual monopoly in their area. And so we didn't want to create that. So we then pivoted on that aspect to figure out a different way to sell cars. And our model in those days was actually Apple, selling directly through stores rather than through dealerships, so we would have no control over it. So we had some aspects like that. But I think that my general advice on this is that along the way, whatever you're doing, you're going to discover that some of your original assumptions are wrong. Or there's new data comes in and you need to rethink it. And the sooner you make those realizations and face it, there's a human instinct to pretend that you don't have this problem and push it off and push it off. And I do it myself, and we did it at Tesla many times. And in hindsight, looking back, the sooner you realize you got something wrong and you recognize it and you make the change, the better you are.
Yeah. Yeah, and the only thing that I would say on pivots is that you never actually know. I mean, with a sports car, you can kind of guess where the markets are going to go. And we did a whole bunch of research to make sure, because we were going to have these dealerships that we would own, we had to make sure they were in the right spot. But with most consumer products, even physical ones, you never know what niche is going to really take off. Mm-hmm. So we had in our past life, we were doing these electronic books, which were quite revolutionary. It sounds Stone Age, but it really was hard in the 90s to do these things. And one of the niches that we would never have expected was on nuclear submarines. It turns out that their space is incredibly constrained, you as a sailor. So books are super highly valued. And a team goes into the sub for months at a time, and they can only carry one book each, and they have to try to coordinate this. So an electronic book that's the same form factor pretty much as a regular book, but can have 100 books on it, is magical. And so, the nuclear submariners market, not one we would have ever imagined. And it's not a very big market, but you can really dominate that niche if you want. But
They probably don't take any Teslas on the submarine.
No, but that's an example of where you have to kind of know, when you get this sort of weird feedback from the market, you can pivot. You still have the same product, but you
can respond.
You might and you might make it a little bit better for that in some way.
Yeah, well, there's another funny thing with the Navy is that we launched the Rocket Book in the days of Napster. If you guys remember Napster, everybody was paranoid about their digital media being stolen. And the publishers were very much that way. So we kind of overdid it on the cryptography on the ebook. It was really, really hard to hack into our system and steal the content. And as it turns out, we didn't realize this, but the Navy took our electronic books to NIST and had them try to break our security. And after 2 months, they actually failed to break into it. And the Rocket Book was qualified for top secret documents in the Navy, which was we didn't plan on that either.
again, we could have pivoted to that. I mean, but it's an example of even when you make something that you can't suddenly decide to make toasters, you can find these unusual markets.
It's interesting. So you really got it right, I think, on your sales model. I was reading $14 billion. I know you're not at Tesla anymore, but $14 billion in committed sales soon after the latest Tesla model was introduced.
Well, I'm not sure if committed is the right word, because the deposits on the Model 3 are refundable.
So all car deposits are.
Yeah.
Okay.
So
by law.
And in fact,
to read.
I read something just actually 2 days ago saying that quite a few people who had put down deposits on the Model 3 are changing their mind and buying a Chevy Bolt because it's available this year.
Of course, it's not actually
Right, there's a
available
lot.
quite yet.
Not quite yet.
Yes,
Yeah.
but
Okay. Yeah. So I was wondering if you could comment on, I mean, even though you're not involved day to day now, is my understanding.
At all,
I mean,
yeah.
you started this.
Yes.
I mean,
Well, I mean, we got a lot of stuff right. There's been a lot of fine tuning, a lot of new stuff that's come along. I mean, heaven's sakes, the company is 1,000 times bigger than what we were.
yeah, right. Yeah. Awesome.
But the direction we pushed the company was more or less right.
Yeah.
is the lithium battery? I mean, so you started with that. And
Yes.
that's still is this the material of the future?
Well, so lithium-ion batteries are a very broad family of chemistries. It's not just one kind of chemistry. And if you're going to do an ion exchange type battery, lithium is kind of a special kind of battery. You guys know where lithium is on the periodic table? Yeah, it's 3, right? It's a really, really small ion. There's not any solid ions that are smaller than that. So my feeling is that as long as we're doing ion exchange type batteries, that some form of lithium-ion battery or another will be around for quite some time.
It has a lot of life left in it.
Yeah, I'm right now involved in a startup company that's working on batteries, and I've been looking at the improvements in the battery chemistries in terms of longevity of the battery and also in terms of cost, and it's just dramatic. I mean, it's still on a very good curve right now.
Yeah. It's kind of a slow Moore's law, doubling every 7 to 10 years in capacity, or price, or whatever the metric is that you're looking for. It changes a little bit, but that's a big deal.
Yeah.
When we launched in 2003, we designed the Roadster, knowing the chemistry that we could get at the time, and then we hoped that it would be better by the time we were in production. And in fact, by the time it was in production, it had gotten 7 or 8% a year better during those 5 years to get it into production.
But there's another change that's happened in lithium batteries that's worth noting. It's been a quiet change that I've observed from direct testing of the cells. And it used to be that, and still the case today with most cells, that their cycle life is fairly low, that after some number of cycles, the battery capacity drops off dramatically. And there's a lot of reasons that chemists will tell you why that is, that there's carbon granule pulverization and there's this and that, the other thing. But the real reason it was that way was that in the prior uses for lithium-ion batteries, that was okay. That that was enough cycles to last for 2 years or 3 years, and that's when your electronic product, your laptop or whatever, was obsolete anyways. Didn't matter. But with the market pressure pushed on this chemistry by the automotive field, we've seen a dramatic change where suddenly we're seeing batteries that have like 5 to 10x the cycle life from before, from small tweaks to the architecture of the cell.
And then there's so much more radical ideas that could potentially make the cycle life really, really huge,
Yes.
which has big implications in fixed storage, which
Yes.
is something I'm kind of interested in.
Yeah.
Yes,
So
great.
I guess that comes to my question on lithium is how available do you see lithium being for the future? I mean, I'm not clear on where it comes from and what the stockpile.
So lithium is a very common element. It's the 30th most common element on Earth or something. It turns out that there's a lot of it in places like Bolivia that's just lying in practically pure form on the ground that you can scoop up and use.
Yeah, in the olden days, copper used we could literally go out and mine copper by walking around and finding clumps of elemental copper, and now they take away mountains, to get a little bit of it. Lithium is still in the zone of walking around literally with wheelbarrows and shovels and putting it into.
But there's something to keep in mind, that lithium is not like oil. That when you use oil to power your car, it's gone. When you use lithium to power your car, when the battery is dead, the lithium's all there, not one molecule left. So you can recycle the batteries right back into batteries again.
Point, right.
As an example, today, if you have a car, you have a lead acid battery in it, and the lead that's in your battery in your car, 98 point something % of it came from another car battery. We do almost a perfect job of recycling the lead in our lead acid batteries because it's worth it.
Yeah, and even it's only worth it because actually there's a bounty on it because the lead is so toxic, really. But even batteries that are stolen get recycled because that's how you monetize the stolen battery, is you take it to the recycling center.
Yeah, and another thing is, this is back to, I think I saw some comments about regulation. If you're in the business of selling car batteries, starter batteries, by law you must take old batteries back. So if you guys have an old battery kicking around your garage you want to get rid of or something, you can take it to somebody who sells batteries, and by law they must take it from you for recycling. Yeah. And that's been true for 30 years or something.
So we know that we can do this kind of thing, as a society, because we have it implemented in all the industrialized societies. And lithium is going to be, fortunately it's relatively plentiful, it's going to be very cool. There are other elements that are a little bit more rare, but they can all be recycled.
And in fact, spent lithium-ion batteries today, a used up lithium-ion battery has a positive cash value. You can sell it. Their companies will pay you money to take it from you because it's worthwhile to tear it apart to get the elements out. In particular, the one that makes it pay for itself is cobalt.
Actually, I have a question about that. I've been
Great.
reading a couple of articles that say cobalt's going to go off the cliff because it's not mined as cobalt. It's like a byproduct of other mining. So I was just wondering, is there any credence to those articles?
Maybe so, but cobalt's not required for the batteries. The cobalt is in some of the formulations. Some of them use manganese instead. And if cobalt were suddenly really valuable, people would, of course, start mining it. And again, it recycles. Cobalt is used in, it's just used in hardened steel. I think that's the biggest market for it. I think if you're making drill bits and saw blades and stuff, you need cobalt.
There were some questions about fuel cell versus batteries. Would you like to address
Yeah,
that?
so I guess, stop me if I start ranting too long on this. Okay, so hydrogen is not a fuel. Let's start with that. There isn't any hydrogen here on Earth.
Well, there's lots of hydrogen.
Yeah, right.
It's super reactive, and it's bound up into everything that you see.
Right. But to make elemental hydrogen, to make H2, you have to put energy into it. You start with water, usually, and you do electrolysis, and that produces hydrogen. And then you take the hydrogen, and you put it in a fuel cell, and that produces electricity again. So if you think about, you have a system, you've got electricity coming in, and some water, and you've produced some hydrogen, and you compress that, and you put it in a car, and you put it in a fuel cell, and that then produces electricity and output. And now you can measure the efficiency of the system. I can put electricity in here and measure the electricity coming out here. Okay? And the efficiency of that, if I'm using the very best technology available today, is on the order of 20 to 22% efficient. Compare that to a lithium battery, which runs on the order of 95% efficient. It's just not worth it. The hydrogen fuel cell car will require 3 to 4 times as much of whatever your source fuel is. 3 to 4 times as many solar panels, 3 to 4 times as much natural gas, 3 to 4 times as many nukes, whatever it is, 3 to 4 times as many per mile to drive the same number of cars.
Yeah, and it's even worse than that because that's sort of theoretical numbers if you're doing really, really well and you don't take into account any kind of transportation costs for the hydrogen, any kind of distribution, energy that's required. That's as if the hydrogen is made right there at the car and can just be compressed and put in, and that's probably unrealistic.
Yes.
So the actual efficiency is probably more like 10%.
So you have to ask, why are there still people making fuel cell cars? And I mean, just as an insult to me, they're putting a fuel cell recharging station 2 miles from my house.
Just to get you.
With government subsidy.
Yes, with government subsidy. So, and the reason is that the California Air Resources Board, in their infinite wisdom, has deemed that a fuel cell vehicle gets 10 times as many zero emissions vehicle credits as an electric car does. Why?
That's interesting.
You have to follow the money, I think, to get the correct answer to that. Yeah. But this is, to me, a perfect example of where government goes wrong. When government mandates a technology instead of mandating an outcome, they almost always get it wrong. Almost always.
I have a follow-up question on that, actually. I had this question before, but you teed it up perfectly. I had the occasion to do some research into CARB's zero-emission vehicle mandate. Yes. Which is sort of a fascinating history for those who don't know. In 1990, they mandated that 15% of the cars sold in California by 2002 would be zero-emission vehicles. Of course, that didn't happen, but they had this interesting process whereby they kind of revised that mandate every 2 years in consultation with industry and stakeholders. And my sense of from doing that research was that led to a number of good things, like a bunch of battery research, a bunch of getting the industry to like kind of set up some of the early efforts that made your work possible. Is that correct? And would you give some credit to ARB for the work they did 2 decades ago, or not?
Absolutely. I think the Air Resources Board, I mean, why does California get away with having its own Air Resources Board instead of the federal level? The answer is that, well...
I'm sorry, I was just going to say the Clean Air Act grandfathers in
But
there.
why are they grandfathered in? Because California invented the idea of regulating air quality. We invented it.
Right.
Okay, Air Resources Board exists.
It was a great need.
It was incredible, and they did a lot of things right. But somewhere around, just about the time when we were thinking about Tesla, around 2000, 2001, 2002, the zero emissions mandate was gutted. Basically, what they said is, you guys don't actually have to make electric vehicles anymore, and all of them were taken off the market, every single one. And if you owned something like a GM EV1, they came and forcibly took it from you and crushed it. Okay, and what they did is they said, instead of this, the car companies just need to put a bunch of research into fuel cells. So I believe...
And hybrids. They get credit for hybrids.
That came later.
That was much later.
That came later.
Yeah, it was after the Prius was already around.
Yeah, the gutting of the zero emissions mandate was all around fuel cells, and all of the car companies started making these research programs into fuel cells, knowing, in my opinion, full well that they weren't actually going to turn into a fleet of vehicles. This was a way to forestall having to do anything real.
And one of the things you can see about that is, if you look at all the electric car programs, with the exception of the EV1, which was the one who got which got eliminated when the zero emissions mandate was rewritten. If you look at, again, following the money within these big, GM and Ford and all these companies, all of those research efforts were paid for not out of their advanced research group or their and all those concept cars and all of the examples that they would do around the neighborhoods showing the hydrogen future or the electric future. They were all paid for out of the public relations budget, not the engineering budget. Yeah. And that means that as an organization, these companies didn't care at all. They knew that they were never going to make these things. It was all just for PR, which is why it came out of the PR budget. It didn't come out of the engineering staff. It didn't come out of the engineering budget because they were doing real work. They were.
So why was Toyota
that's a hybrid. That's a little bit different. And it has a funny.
There's a funny story. So y'all know that Al Gore invented the internet, right? Okay. So, but what he really said was he made it happen. So, how many of you guys saw that movie, Who Killed the Electric Car? Okay. There's a little piece in that movie. The movie's not all true. But there's a little piece in that movie that to me was an eye-opener. My jaw hit the table when I watched it. This was a video, an actual piece of video of an event that happened early in the Bill Clinton presidency. And this was on the lawn of the White House. There was Bill Clinton and Al Gore standing at a podium, and in front of them were the CEO of Ford, GM, and Chrysler, sitting in front of them. And Al Gore was making a presentation basically saying we need to do something about our fuel economy, and he had standing on a stand a prototype hybrid engine from some university saying, you guys need to do this. You guys need to do this. This is how we do it better. That's in that movie. You can watch it. The result of that was the Ford, Chrysler, and General Motors put their lobbyists to hardcore work to make sure there was no law passed forcing them to make hybrid vehicles. Toyota was not invited. They weren't there. Toyota watched this on TV. They saw that and said, oh, crap. And they went into the engineering department and said, we got to make a hybrid, you guys. So in a way,
opportunity.
Al Gore invented the hybrid, too.
Yeah.
Wow.
But just go watch that. I mean, you look at the date on it. You'll see it's very, very interesting.
Well, and the funny thing about it was when the Prius came out, and this is one of the things that we learned when we were trying to figure out if we were going to be able to sell electric cars, is that the Prius comes out, it gets great gas mileage. Gas is free, right? It's $1.20 a gallon at the time, and which is pretty extraordinary. It was almost the cheapest it's ever been in real terms. And they start selling only in California, largely for political reasons, I think. They sell it to California, and it immediately eats into the Lexus market share. And so their absolute richest consumers were buying their cheapest car that got the best gas mileage.
Do you remember what the original version of Prius looked like? It doesn't look like today's Prius. It was based on the Echo, which was the cheapest platform that Toyota had.
Toyota didn't really know who was going to buy it, but they never guessed it was going to eat into Lexus sales. They were thinking it would be kind of poor people who couldn't really do math very well because it was sort of expensive, and they would never, at $1.20 a gallon, it would never pay for itself. And it was people who spent far more on lattes than on gasoline that were buying them because they didn't want to use up gas.
But
They didn't want to. Didn't want to be involved in oil for whatever reason.
I mean, this leads to a little bit about the founding of Tesla. Is that when I was thinking about who is our customer for Tesla, I drove around the streets of Palo Alto and took pictures of people's driveways where you saw a big old BMW parked right next to a Prius, or
always a
Porsche parked next to a Prius. And I looked at that and said, that is my customer. That's somebody who likes a fun to drive hot car, but also maybe feels bad about the gas mileage.
So you're leading to several people had questions about the energy density of gasoline versus batteries and all
Okay,
of that.
let me take that a little bit. So,
Okay, go ahead.
Great.
So gasoline is super energy dense, right? It's what's great about it. Was it 35 kilowatt hours per gallon? I think
Something like that,
Something
yeah.
like that. So it's really, really dense. The thing is that to actually make it useful in any way, we want to typically make it go like the car go forward. That conversion process from all of that energy is terrible. So if you think about it, you know that that has to be true. Because when you get into your car, and you can do this as an experiment after class, if you have an internal combustion engine car, in the parking lot here, just disconnect your cooling system on your car. So stop, all the radiators and stuff.
Take your radiator
disconnect
belt
that.
off.
And then,
fan belt
then go and drive it and see how long it takes before the engine melts into a puddle. And it's only, you won't even be on Alpine Road before it's all done, And it's because almost all of the energy that you get out of the gasoline, which is great, lots of energy, very dense, almost all of it is wasted as heat. Which is why, you can have heaters in gasoline cars that you don't have to have heaters, you just use some of that very high quality waste heat. The thing is, so the difference is that yes, gasoline is very, very energy dense, and if you have that much energy on board, you want to be able to do something with it. The real question is how much can you do with it? And with gasoline, only a small percentage gets converted into forward motion. You think about electricity.
Ballpark 20% efficient.
Yeah, and
Gasoline
really
engine.
good. So 80% gets wasted. Electric motors are over 90% efficient. So that's why if you think about a Tesla, which gets 240 mile range, it only has 2 gallons worth of energy. Those batteries only hold
2 or 3 gallons worth.
Yeah. The original model had had 60 kilowatt hours. 50 kilowatt hours, and it had 220 mile range because the conversion of that energy that's on board into forward motion is so extremely high, which is why electric cars don't have radiators. They don't have all this cooling system for keeping the engine cold. They have to have resistive heaters to make cabin heat because there's no waste heat to use. The neat thing about that though is even on a cold morning, you turn the heater on, it's like instant because it's just just a wire that it heats up. You don't have to wait for the engine block to heat up. So it's tremendous. So will batteries ever get as energy dense as gasoline?
No.
Maybe not, probably not, but it doesn't matter because you don't care about the energy density of the gasoline. What you care about is what it can do for you. And actually, unless you want to generate a lot of heat, most of the time it's not very useful.
Don't actually do this experiment on your car.
Oh, all right.
Well, I'm
just
just
saying.
foreseeing a future Tesla sale, right?
Yeah.
The infrastructure is the other thing, right? There's gas stations everywhere. Somebody was asking about this
So
too, right?
we have to recognize that
You're not everywhere yet.
each kind of vehicle that comes along requires its own infrastructure. When we all were driving around with horse carriages, we had to have stables, we had to have straw, we had to have someplace to put the horse shit. Gasoline cars require fueling stations everywhere. And it's not true that the electric cars need the same model. So although it's true there isn't much infrastructure out on the street for these things, for those of us who actually have houses, the infrastructure is already there, right? Electricity is already delivered to everybody's house. And unless you're taking a road trip, when we drive our electric cars, we get up in the morning and the car is full. And it'll go, well over 200 miles, so drive all over you want to, and you get home again, you plug it in again, and it charges up again. The only time you need to charge your car, if the driving range is enough, is where you sleep. So that means that charging stations need to be at people's houses, or if they don't have a garage, then it needs to be at the curbside by their apartments or wherever they're living, and at hotels and places like that. You don't need to have them. You don't need to have charging places like gas stations. Does that make sense?
Any questions? Yes, please.
So I have a question about how you see the role of the electric car vis-a-vis public transportation and move away from cars altogether, and how you see that.
So I think that's an excellent question. And I think that question also applies to autonomous driving and sharing economy is that we can come up with these ways that make cars better, but it is a very good question to ask in what circumstances are cars in fact the right place to go. And it may be that in the long run, cars have a very small place in the market, but our goal was to make a change now. And the thing that we understand is that human nature changes slowly. So if we can get people just to get out of their SUV and get into an electric car, that's a good start. But in the big picture, cars probably will play a smaller role in the world. Would you agree?
Yeah, yeah. At least that's. It seems like they should. And when you're in places that have really integrated and very fast public transit, you go, oh, this is so natural. But like where we live in near Stanford here, it's kind of hard to imagine how that all is going to work without having some kind of personal device, whether it's shared or not. But
teleporters.
Yeah. The trains are not going to really come to my house exactly. So
yeah.
So I'm a grad student at Cal, and I've got a chemistry question, but I'm not a chemist. So
we aren't either. So
yeah,
we
just make it up.
Yeah.
just any thoughts about, because I'm working on a class project, kind of, you talked a little about lithium batteries, kind of some of the different kind of chemistries, like the merits and maybe market potential of like cobalt versus a lithium manganese versus like lithium sulfur or lithium air, anything else you want to talk about?
So when you're looking at the lithium salt chemistries, so that's lithium ion, lithium cobalt, NCA, NCM, all these different, these are all slight variations. And every cell manufacturer has a half a dozen such chemistries that are optimized for different things, and they're continuing to tweak them. You can't really separate them apart because they're mixing this to that to the other thing. If cobalt's too expensive, they'll replace it with something like manganese. This guy's going to die trying to get his phone shut off. I hate that.
Only the battery had run out.
So I think that it's unreasonable to try to separate all those different chemistries apart from each other because they solve different purposes. Talking about lithium air, that's a different world. Lithium air batteries falls in the category of metal batteries. It's not ion batteries. So what you're doing is you're basically corroding the metal and then plating out solid metal again in the two directions. And that's a problem that's not been solved. You can make that work for one cycle, but the next cycle gets much harder because the way that metal ions of any kind of metal plate back out on other surfaces, not flat. They, by nature, form these things called dendrites. It's almost impossible to stop. And those dendrites will, within a very small number of charge-discharge cycles, cause the battery to short itself out and catch fire. Nobody's cracked that nut yet.
One thing to think about too is that just in general, the chemistries kind of fall into sort of energy. So cells that are really energy dense, they can store a lot of energy, but they have other restrictions. You can't charge them as fast typically. You can't take the charge out of them as fast. And you generally, they don't have as many cycle lives. That's not always the case. And what are called power cells. So the power density is very high, but not the energy density. If you think about your drill, your lithium-ion cordless drill, that's going to be power cells because they want to be able to charge really fast, and they want to be able to have tons of power available to turn that drill bit.
Yeah.
But they don't have much energy.
But then again, this is the result of people responding to the market demand.
Well, exactly. Yeah.
There was
a push chemistries.
There's a push for cells that are great for laptop computers. There's a push for cells that are great for cordless drills. Now there's a push for cells that are great for cars, which is something different entirely. They have different trade-offs, and this is what I'm beginning to see now. So it's a moving target, and it's the market doing what it's supposed to do.
And the market for car battery, for electric cars, the cells is so much larger than all the other markets combined that all the battery companies are they're focused on it.
Well, so I mean, just a little anecdote. When we started Tesla, we knew that the batteries mattered a lot, and I went to visit one of the cell manufacturers in Japan, a big Japanese corporation. One thing I understand about Japanese companies is that the real decision maker on a company like that for big decisions is not the sales guy you meet here, and it's not really even the CEO. It's the guy who runs the factory. He's the guy that pulls the strings at the company. So I went to meet this guy, and I told him what we're doing a little bit, and he looked at me flat up and says, we're not interested because already we're in a market that has very low margins, and we understand that the automotive business is extremely margin sensitive and a lot of pressure to get the margins down as close to zero as possible. So we really don't want to do that. And I said, yeah, okay, I get that. I understand where you're coming from. But let's think about the problem a different way. These individual little cells that you make, How many of them are you going to sell to each consumer? You're going to sell them a couple laptop computers, so you're going to sell them with maybe a DVD player, a couple other things. 20, 30, 40, 50 cells, something like that. That's how many per consumer. I'm talking about selling 8,000 cells per consumer. Can you think of any other opportunity that would cause your business to jump 100-fold its market size? And the guy thought about it for a while and says, you're right.
And it turns out if you can convince somebody like that that their potential market is 100 or 1,000 times larger than their marketing department believes, you get a call from the CEO asking to explain that.
That's right. And they had showed me a pie chart that showed who their customers were. And there was a couple of big segments. And today, the biggest piece of that wedge is Tesla, even though there's a whole lot more laptops sold than there are cars, because there's so much per car. And I think that the next big market to come along, even bigger than cars, is going to be stationary storage for grid energy storage. Yeah. That's in the next decade. It's going to be even bigger.
Exactly to this question.
Different cell chemistry, but yeah.
Yeah.
Maybe similar.
Similar. Yeah.
Yes.
So there's one about, but I want to get back to your chemistry too. One a student put in here that I like. What barriers do we need to overcome, regulatory, economic, technological, for consumers to be able to connect their electric vehicles at home and both buy and sell electricity to the grid? So it's getting towards your storage. Are we headed towards a system, or do we need to make changes? Is it desirable?
Yeah, that's a great question. So there's this whole concept of vehicle-to-grid storage. The idea is that the vehicle could charge off the grid and put energy back onto the grid. And the reason you would want to do that is that electricity has different value at different times depending on the difference between generating capability and consumption. So in the afternoon, when everybody's got their air conditioners running, electricity is really valuable, and you might want to sell electricity to the grid. Mm-hmm. The trouble with that is, there's two troubles with that. One is that every cycle through your battery has some cost. It's not zero. It does beat on your battery, and it does reduce its life. That's one. Second thing is that when you actually are putting energy onto the grid, as does, for example, the inverter on your solar panel, it puts a pretty heavy-duty regulatory burden on the design of the device that's doing that, of the car. So it actually adds some non-trivial cost to the cost of the car. But there's another thing to think about, and that is that you can get about 90% of that value not by allowing the vehicle to put energy onto the grid, but rather just allowing the grid to have precise control over the charging of the vehicle. So that it can say, stop and start, or stop and start at this level in real time. Okay, and what happens then, if you have a large number of vehicles that are plugged in, just statistically speaking, is that all these electric cars can be used as grid regulation. And they can allow the power company to have a much, much smaller amount of what's called spinning reserve, that is to say generating capability that's not being used. Because they can turn the cars on and off as demand. So for example, when a big cloud passes over the giant solar panel array in the Mojave Desert, the grid then tells a whole lot of cars to, hey, stop now, and they get off the grid. And when the wind starts honking on Altamont Pass, they can tell a bunch of cars, hey, start charging now. And you get about something like 90% of the value of the vehicle-to-grid idea without actually taking energy out of the vehicles.
Is this being used now, or is this theoretical?
It's perfectly doable today. It's a
doable but not done.
Right, and the reason is because the way that the grid economics works. It's an artificial market. It was created when PG&E was broken up and other power companies, so that kind of who feels the pain of having to regulate the grid isn't the one that has the money to spend. I actually know a guy who wrote his PhD thesis on this problem. It's a messy problem that's not technical.
Yeah,
we could design the system today to do it. Absolutely.
It's easy.
There are experimental programs all over the place, but to implement it in a way that's on large scale is like I say, it's not a technical problem.
Well, yeah, and also I know of a place that has a lot of golf carts. It's a giant. It's in Texas, right? So it's got a gazillion golf carts.
And they're really big golf carts.
Big, yeah, it's like, and it turned out that their local utility, whoever they were, was willing to cut them a deal if the local utility could say, hey, stop charging, because they effectively would all turn them on at the same time. And they said, if you could not do that, and so they have a deal. Well, but it's very one-off. But
it's not quite. If you go to, if you drive out toward Vacaville, the Anheuser-Busch plant there?
That's good, yeah.
So Anheuser-Busch is a giant factory that makes beer, and they have a lot of equipment that draws a lot of power, and they have a special deal with CalISO that CalISO can ask them to knock it off. But this is not real time. This allows them to do big level, getting rid of the big bumps. It's perfectly feasible to allow the cars to charge and not charge on a per cycle basis of the 60 hertz and have absolute perfect control over the grid. I mean, we could design that
Yeah,
system today.
it's not a technical problem.
No, because I mean, we used to think that one cycle, 1/60th of a second was a really long time, but in the land of computers, that's like it's like 100 million instructions of some computer.
Right, yeah, not a problem.
So let's go to policy. Some of the questions are, what policy needs to happen to do EVs need favorable policy to compete with gasoline-powered vehicles? What policies make sense? What's the situation right now? Are they helping or hindering you?
Our logic at the beginning of Tesla is we had to make a business that made sense even if we didn't have incentives. Right. Incentives are nice. It's an accelerator. Somewhere early on in the days of Tesla, I was invited to testify before the Senate about exactly this, about policies. And this was in the days when many small businesses were buying Hummers because there was a special loophole in the tax code that allowed you to write off a Hummer, to expense a Hummer if it was above some ridiculous weight, then they got a super favorable tax deal. And because they're Hummers. It makes no sense. Well, I think that the law had originally been written to help out the plumber for his truck, but accountants had figured out that in their accounting business or their nail painting business or whatever, you could write that heavy vehicle off in the same way. So I asked the Senate at that point just to give electric cars the same benefit that Hummers get. If you Google it, you might find my testimony out there somewhere. I don't know. But I think that what policy can do for this kind of thing is accelerate the process. I think it's going to happen anyways. I've been looking closely at the cost of batteries recently, and it's my belief that the cost of making an electric car will match the cost of making an equivalent gasoline-powered car probably in the year 2020 or 2022. It's coming up pretty fast. And at that point, it's going to be, from then on, it will be cheaper to make an electric car than a gasoline car, and they will win. Because what we know about this is that the price will only go down on those. It's just technology. It's not like the price of oil that can come up and go down. It's just technology.
And then because of the efficiency of the car, the electric cars tend to be more expensive up front, but then the per mile cost is extremely low because it uses so little energy.
And that's a total cost of ownership argument that you can make to people who think about it and say that I can buy this more expensive car now and it'll pay for itself over its lifetime. But by 2022, it's just going to be plain cheaper, and
exactly.
that's it.
And that's the tipping point. That's when it all becomes, like everyone's going to do that because it's cheaper and it's better.
I see a hand up over there.
Oh, great.
Hi. So I was just wondering, what was your biggest problem, like making the cars and starting this up science-wise? Like not just business stuff.
Oh.
Yeah. Was there any big?
Well, I guess I'm going to answer that by saying that we tried to avoid any science projects. We tried to. And I mean, the rest of the world was basically saying if we're going to do electric cars, we eventually need to make these specialty automotive cells, and we didn't. We used cells that were already being made by approximately 1 billion per year in production. And so what we have were engineering problems, lots of them. But we deliberately avoided anything that was a science project on purpose. Because I don't believe that you can predict the completion date of a science project.
Right. But almost by definition, because science you don't know exactly.
Yeah.
And yet, were there problems that you said?
We had engineering problems.
Oh, there were lots of engineering problems.
But no science problem.
No, I don't. I mean, there were. I mean, I guess by a scientist's definition of science, definitely not. We ran into some surprises on the engineering side of things that required some cleverness.
Right.
How do you make the electrical connection to the cells? Or
a phenomenal mechanical engineer I know spent 3 years of his life getting that connection exactly right for Tesla.
And there's better ways to do it.
Well, right, yeah. Well, even things that you think the automotive
just the attention
industry.
to detail.
It's the automotive environment is incredibly difficult because it has all this vibration and it's got road stuff and it's raining and so just
hot and cold.
Getting the connectors to not behave badly is incredibly difficult for any car company. So there were engineering problems like that were.
But
those aren't science problems.
I mean, in the science world, it was by design, by deliberate choice on our part. We chose why is the company called Tesla? It's called Tesla because I decided that we were going to use AC induction motors. The AC induction motor is a kind of motor that was invented by Nikola Tesla. He patented it 100 years ago, roughly. I mean, it's a 100-year-old design of motor. And if you look at our motor, if you handed that to Nikola Tesla, he would look at it and say, yeah, that's my motor, exactly so.
How did you make it quite like that? Or
but
actually, what he would really
get
say
royalties.
is,
Here's the thing about patents. They only last for a certain while.
He would wonder how we spin it at different speeds.
You know what Nikola Tesla would be doing today if he was alive? Scratching furiously at the inside of his coffin.
Oh,
just kidding.
It's endless, actually, with him. It's just like that all
When
the
the
time.
lecture turned dark. Burning questions.
So I was working on an electric vehicle charging startup this summer, and one of the questions that we ran into was, so home charging might be the right choice now, but say 5 or 10 years from now, if cars are autonomous and shared, they're probably going to be owned by fleets and not by individuals. So then how does that shift to charging infrastructure?
Well, so fleets are really interesting because you see that in buses and in light trucks and stuff. And they're actually great for electric cars because in general, it's a little bit hard to understand exactly how the autonomous world is going to work, but it's certainly in modern day fleets, you sort of know what their average mileage is going to be. In fact, you generally know their maximum mileage, so you can even sort of spec the batteries for those to the right size. They also tend to be in centralized locations where they get charged. So you can do all kinds of fancy stuff. Like you can sort of do the load trigger, the load thing that Martin was talking about on a grand scale. You can do that on a small scale for your own power needs, at the light industrial facility where you're charging them all. They also tend to have lots of big power mains there. So fleets are not a problem. It's a little unclear to me in an autonomous world, though, where you have fleet utilization. Cars sit around almost all the time, right? Nobody drives them, so there's plenty of time to charge them. In an autonomous world where you're trying to get 60 or 70% or 80% utilization of them, where do they charge? You don't want them to have to go back to the depot, although you probably want to clean them and
But
stuff.
you're not going to have 80% utilization 24 hours a day.
Well, I mean,
you have to have enough cars out there to satisfy
exactly.
the commute time. And at night, those cars are mostly sitting.
Right. So it's probably you're going to have time to plug them in and just charge them back up again.
But there's another piece to your question, maybe not quite on your question, but makes me think about it, is that, of course, not everybody has a garage. There's a lot of people who park their cars on the street. If you don't believe it, just drive around San Francisco. It would be actually not that big a deal to put a charging infrastructure on the curbs like parking meters.
And they do it in other countries.
Norway, for example.
Yeah, in Norway, every parking meter has a power because you have to keep the engine warm, otherwise it freezes into a. Seriously, I mean, they all have block heaters. So every parking meter has a plug on it already, and they've had it since the 50s.
Go ahead.
What about stations that would just replace the battery from an empty one?
Well, this was the Project Better Place idea of replacing the batteries. And there's a couple comments on that. Is that the reason you would want to do that is because the batteries don't have enough range. And the reason they don't have enough range is because they're too expensive. The real problem of batteries isn't energy density, it's cost, right? And so what you're doing in a world of battery swapping is you're taking the most expensive part of the car and you're making it even more expensive because I got to have, 20 or 30% more batteries around than I have cars. So I can swap them in. So you just made the cars more expensive. Second thing is that today, the problematic part of a car is the battery. And making them swappable means I need to standardize them already today. Okay, so that means I've stopped evolution on the batteries.
And so an example is that there's no fuel tank that's the same between cars. Every single make and model of car has a different kind of fuel tank. So imagine if you had a much bigger kind of fuel tank and you had to make them all standard so that the cars would all end up being square, like these boxes.
Now the thing is that once you get to the point where the batteries are good enough that I can actually contemplate having some standardized modules, I can take them on and off of the car. I can also build a car cheap enough with enough range it doesn't matter. Like I say, 2020, 2022. I can build a car with enough range at the same price as a gasoline car, and who cares? I mean, if my car has let's just say 500 or 600 miles driving range, why would you ever swap it? That's all the driving you'd ever do in a day.
Follow-up for that, because you mentioned 2020 to 2022, it will kind of reach parity with SUVs. So is that based on the sales volume that's being projected, or is it based on something right now? How much?
That's based largely on looking at the curve of cost of batteries, not anything else on the vehicle. The rest of the vehicle costs are the same as any other car, except the motors are cheaper, of course. But battery prices are definitely coming down in a very, very good way right now.
So that won't just be Tesla, there'll be anyone.
It'll be everybody.
Anybody? No, it's not Tesla. It's the world over. Yeah. I mean, today I think the most interesting vehicle to look at is the Chevy Bolt, not a Tesla. That's a $30,000 car with a 230-mile driving range coming out this year. Pretty impressive.
So when you started Tesla, how were you able to convince investors to fund your company? I mean,
It
there are
was
so
very
many
hard.
other ways to earn money so much.
Yeah.
So we showed the Tesla prototypey things we had and our pitch to how many? What, like 100 VCs?
No, I wasn't that bad.
Something
It was
ridiculous.
not that
It was
bad.
insane.
Yeah.
But you know, the guy who's the CEO of the company now wasn't the founder of the company. He came in 9 months after we started the company as our investor. He was somebody who got what we were doing and was willing to put his own money behind it.
Yeah. So when Elon led the Series A, you know, so raising money is really hard. It takes a long time, and we were pretty good at it. So we did make sure that our presentation was crisp and good by the time we started, and we had worked out the bugs in the presentation, and we did that by going to a bunch of VCs that we knew would never fund us and say, you know, we have this thing. You're never going to fund us, but can you give us feedback?
Yeah.
And we actually changed that's how we changed the distribution model, because the VCs pressured us on the distribution model, and
we had to go learn about it.
We understood, we thought we had the answer to that, but we really didn't. So when we really researched it, we're like, oh shoot, well this is not going to work. So, you know, by the time we actually went out to raise money for real, you know, we had a pretty good story. And
But it was also a pretty improbable story.
It was totally insane. But given that, with some very careful targeting of who we were approaching, we did get a couple of small VCs to say yes in small amounts. And we were raising, you know, millions. So it was not, you know, it isn't one of these internet startups where you go and you raise 200,000 and you're like done. Yeah, we had to
raise 400 million to make coupons.
Yeah, yeah. Which was happening kind of at the same time. It was very frustrating that they, you know, could raise all that money. But so
and you self-funded to a fair extent.
Yeah. Well, we did initially, and then you know, when you actually begin to have to do big things, you got to raise real money.
Yep.
And then you know, we went to very small firms, because firms typically need to have everybody, all of the partnership has to be in agreement to make an investment. And if you have 8 partners, they can write a big check, but you got to kind of convince 8 people that you're not crazy. And that's hard.
And that investing in a car company isn't crazy.
Yeah. So what we discovered was pretty quickly that actually the smaller funds that only had 1 or 2 partners were a better bet, because we could probably get 2 of them to say yes at the same time. It was a better. So we had a couple of small funds involved, and then we were looking for angels, big angels that could write large checks, and that's how we found Elon. And we actually knew him through a different connection originally, but and you know, he believed in the vision and led the round.
I guess it was easier because it was your third endeavor, maybe.
I don't.
It's always hard. It was not easy. Don't get the idea it was easy.
It was incredibly hard. The thing that made it easier was that we've gotten really good at accepting rejection. So, you know, the first time you raise money and people keep saying no, you're like, oh, this is so awful. But you know, by the time you're doing it, like the third time, you're just like, oh, of course he's going to say no. Everybody always says no, but that's okay, because eventually you find people who believe in the vision.
Yeah, but we've had a history of starting companies that are not in the mainstream of what the venture community wanted to invest in. You know, the word clean tech hadn't even been invented yet. It was you know, this idea of doing an electric car company. It was so out of the ordinary when people were investing in. I mean, they'd barely just gotten over the idea of actually making anything. You know, before that they had been wanting to invest in only software companies, or even before that, or even just, you know, .coms, you know, just websites.
Yeah.
Another funding question is that whole time when all the car companies were in big trouble and, you know, the government had to give loans to bail out. Is there anything interesting to tell about the story there? One notable thing is Tesla paid their loan back first.
Well, no, wait a minute. Ford didn't borrow any money.
Yeah, Ford was Ford really had its act together going into the crisis. So it actually was not caught, you know, flat-footed.
I bought a bunch of Ford stock then.
Yeah,
I did very well.
So the one thing is that Tesla. The government loan wasn't to bail out Tesla. It was to create the factory for the Model S. And so there's like this tremendously long and bizarre story as to how these loans got funded and how they got created. And you know, we had left by the time that loan actually got approved, although
we started that ball rolling, yeah.
Because it's the federal government. Like years and years go by, and you don't know if you're making any progress. And it was on a totally different program. And then what happened was, when the financial crisis hit, and actually Tesla was in fairly good, they had the money for the Roadster and they were producing Roadsters, and actually that part of the world was not falling apart for them. What was is that when there was this idea of this next car. Do you partner with a company like Lotus? It wouldn't be Lotus because they
Ford.
don't. But it would be, do you partner with some other company to make the car thing, or does it make sense to actually build the factory to actually make the car, to screw the car together? We're going to do the drivetrain and everything anyway. We did the drivetrain on the Roadster, but the question was the actual screwing together of the car, and that is a very, very expensive prospect, and so the original models, really the financial models, were not that great for building a factory. But then the financial crisis hit, and that actually played to Tesla's benefit, because there was suddenly some government loans available to help build factories.
And there was a giant factory sitting here in the Bay Area that was being abandoned.
That was happened to
The Toyota basically gave it to Tesla.
Exactly. When GM, the way that joint venture between GM and Toyota worked was that if either company went bankrupt, the other one sort of inherited it all. And that was, I'm kind of glossing over millions of lawyer hours, but that's kind of the thing, right? So and GM put those conditions in because they thought Toyota might go bankrupt at any moment, right? Because they were going to learn all this stuff from GM, and Toyota isn't going to execute well and stuff. Because this was a long time ago that NUMMI was made. So by the time when GM actually collapsed, Toyota ended up with this thing that they didn't want.
White elephant.
Yes, and they found a
But it's actually bigger than that, because Toyota also had a problem. They were just facing a huge amount of press against them because of these sudden acceleration problems with all Toyota cars. And then they were going to be the ones that were going to lay off a couple thousand workers while they're at it. It was just bad press on top of bad press. Yeah. And for them to give this factory to somebody who was making electric cars was a win on several fronts for them. They were suddenly involved in the green revolution, and they weren't the ones responsible for laying off a whole bunch of workers. And it turned the press that was so much against Toyota much more toward them.
And then the government loan, which because of the financial crisis, all of those programs got put onto, they were looking for things that were ready to be funded. And, we had applied for those, this program, we'd applied for years before, and there was this opportunity. They said, well, these guys look about ready. And we had a factory. So it worked very, very well.
Yeah, well played.
That was after our time.
There's so many hands up. You haven't asked one yet, have you?
No. I'm a little surprised that nobody has reacted to your statement about the efficiency of the car when you talked about the energy density of the fuel, but of course you had the engine that had to dissipate that much heat. Now, most of the energy we use is produced by fossil fuel power plants. Mm-hmm. Okay? Mm-hmm. And so now what you have to compare is the thermal efficiency of the cycle of the power generation at the power plant or in your car.
So do you remember I started with this idea of a well-to-wheel energy analysis? That's what I'm talking about. Well-to-wheel energy analysis. I look at the energy of whatever fossil fuel comes out of the ground. I look at the conversion of that fuel into something I can put in the car. And I look at the efficiency of driving the car forward. And you can compare that for any fossil fuel-based fuel technology.
And the argument can be made that a power plant can be more efficient than the individual car.
It's tremendously efficient.
The difference is not that enormous, but you have the transmission cost of the power. Mm-hmm. And I had on another conference or a workshop we had here, Secretary Chu was talking in favor of electrical cars and said, well, why are you so enthusiastic? And I pointed out this problem of transmission losses. He says, well, at this point, he said, it's actually less efficient to be driving the electric car. We should do it because over time the efficiencies of the power plants and the reduction in the losses transmitting at higher voltages and so forth will in fact result in...
The grid is very efficient. The electric grid is actually quite efficient.
Follow-up, sorry. Yeah. So I used to work at the California Public Utilities Commission, and the average for California is about 6 to 7% loss on transmissions.
67% loss?
6 to 7%.
6 to 7, yes, that's right. So
I was going to say, it's in the 90s. It's like 94% efficient. How can you say that? Yeah.
So when I did my well-to-wheel energy analysis, every step along the way of my calculations I did based on real research done by credible sources, generally by people who were opposed to the technology. So for example, the number I used for electric grid efficiency was from an Argonne Lab study that was paid for by General Motors and Chevron. And they said the electric grid in the US is on average 93% efficient, which is more or less your number. 93% efficient, which is pretty good. For the generator technology, I did it a couple different ways. I said, okay, a typical old school generator. I said, okay, a typical generator being built, and then best of breed. Best of breed generator today is for natural gas is a H system generator by General Electric. You can look it up. That's a 60% energy conversion from natural gas to electricity, measurable in production right now. There's about 4 of them in the world right now. One of them in Tokyo, a couple here in the U.S. So it's very, very high efficiency. So, but I mean, the thing is that it's the hard numbers that matter. You need to, on each of these steps, find hard numbers and look them up.
We have to look at the installed power plants, right? Not that what you could build. What
is that true?
The 4
is that true? If I was going to change to a new fuel, let's say we went to hydrogen, okay? I'm going to build all new technology to produce that hydrogen. So it seems to me if you're going to compare that to electricity, then it should only be the marginal generators that you count, the ones I'm going to build now. But even so, it turns out that if you look at the efficiency of my car, if I used coal-fired power plants on today's typical coal-fired power plant efficiency, put that on the grid and put it in my car, the efficiency of that car is about the same as a Prius. It's within 10%, within error bars of the same efficiency. So
and that's the worst case.
That's the worst
generation.
case. It's coal. You can do much better with coal. There's a big plant in Japan that is a combined cycle gasification coal-fired plant. So they basically pulverize the coal and then burn it in an oxygen-poor environment to produce carbon monoxide, and then burn the carbon monoxide in a combined cycle generator. And that's a over 50%, almost 55% efficient plant from coal. And it's clean, by the way, because it takes the sulfur out.
So I have a CO2 balance question that I've been longing to sneak in here.
Uh-huh.
And that is there anything about the materials, the way this is built, that actually gives you an unexpected result where you'd have to drive it for years to break even on CO2 emissions compared to a regular gasoline-fueled car?
I wouldn't speak it's much different, really. That's a really good question. I'm sure you've talked about the idea of cradle-to-cradle design.
Slightly.
Okay,
yeah.
so you guys know that you've heard this idea of cradle-to-cradle? Okay, so if I don't think about cradle-to-cradle waste, it's cheaper to build a car with steel, and that's the way most cars are made. If you think about the car at the end of its life as being a nutrient for the next cycle of cars, then aluminum actually makes more sense. It takes a bunch of energy to make aluminum from bauxite, but if you take an aluminum car and melt it down and make another aluminum car, you recover most of the energy that was used in making that. So you got to be careful when you think about that kind of equation of what are your resources. Am I mining the ore, or am I starting from a used up previous car?
I'm just curious.
There's nothing that stands out
that's
that's somehow weirdly carbon intensive to make an electric car versus a regular car.
Most of the cars are the same.
Nothing in the battery manufacturer, nothing.
No, and like I said, the batteries, the spent batteries actually have a positive cash value.
Yeah.
And the motor is just, it's copper and aluminum. Copper and steel.
Pretty good.
And a little aluminum.
Many questions. Yes, you on the end? Then you.
A bit more on the business side, would you talk a little bit more about leading up to Elon Musk's involvement in that transition? What motivated you to hand over the company, basically?
He voted me off the island.
So not good terms?
No.
Okay.
I don't want to spend a lot of time talking about that.
Got it.
Yeah. There's a lot written about it, most of it not true.
So let's go to you, hopefully on a different
answer
topic.
this individually, but I was wondering if you're optimistic about the climate future, and what are your reasons for being optimistic and pessimistic?
Yeah, I wondered about that.
So I don't know. I'm somewhere in the middle. Now that I have children, I have to be optimistic, because otherwise I feel really bad for my kids.
It's a great motivator, isn't it?
Yeah, that's right. I don't know. It depends on the day for me whether I'm optimistic or not. I see such stupidity in the way that we behave sometimes that I get depressed about it.
Yeah.
You're much more of an optimist than I am.
I'm naturally a little bit more optimistic, but it is going to be adaptation. I mean, like if you're in South Florida, or South Miami Beach,
Sell your real estate soon.
Yeah, I would be thinking about selling and moving on, including the mayor of that town said the same thing. It's like, we can do all this adaptation, but, in 20 years, it's kind of over, right? As far as the projections, we don't have any technology that we know of to
So
to
I guess
stop
maybe
it.
a measure of that is that my house is at 2,200 feet.
Yeah. So the question
We're more
is that
optimistic, we're at 1,000.
the thing is at this moment, we've got technology that is astonishing, and we know how to do it. The thing is that I would be much more pessimistic if we looked at it and said, "Oh my gosh, there's like, how are we going to do this? How are we going to grow all this food? How are we going to, we don't have anything. It's not possible." We actually have tons of different possibles. There's policy issues. There's this quote from I can't remember what the science fiction author. He said, "The future is here now. It's just not evenly distributed." Well, and that is in many ways true. Like, we know how to do this. We know how to have a really advanced society that is carbon neutral. It's just hard, and it's only in a few places, or at least. But the thing is, it is possible. So I figured that we're gonna have to adapt to the climate change, because that train has left. The CO2 is the.
I heard that climate change was a ruse by the Chinese to ruin our economy.
Yeah. The local politics might actually influence things for a while, but
and then there are some Band-Aid technologies some of us are working.
Well, exactly, and then if you get desperate, you do geoengineering. Which
try to make it reversible and responsible.
Yeah, exactly. But I actually, I have to be optimistic, because
what else is there?
What else is there? You're not just going to say, I give up.
So you're leading into what the two closing questions I want to make, and I'm noticing that we're pretty close. Which are, what's the most meaningful thing you guys do today, and what's the most meaningful contribution our students can make?
I mean, trying to make something meaningful out of your career, doing something that you're actually working on solving a real problem, rather than just trying to get rich, to me is the most meaningful thing any of us can do. I mean, when we, just a little bit of another way of looking at the way our careers have gone. I started off making some technology stuff that was the first company that hired me, and it was fun from a technology perspective, and that's it. And when we did the electronic book thing, we had decided that we wanted to do something that was at least interesting. And making books and working with authors and publishers was interesting. When we decided to start our next company, we wanted to raise the bar. We wanted to do something that was beyond interesting, it was meaningful. Right. And that was the root of where Tesla came from.
Right. It took us a while to get there, but that was...
we thrashed about a bit looking for what it meant to be useful.
The thing that you could be the most useful, I think, of the Stanford students is to find ways that don't rely on advertising in order to monetize it. To actually try to sell a product that somebody wants to buy, and that hopefully makes the world or their life better in some way, as opposed to figuring out some vulnerability that people have and be able to inject an ad right there. That's my personal thing.
High five.
Yeah. But that all said, it is doing something that has some kind of meaning. I mean, at the moment I'm very involved in education, which I find to be. I have kids, so I'm particularly interested in education right now. And as the kids get older, perhaps I'll get into the next thing, because I don't like to stay doing the same thing for very long. But it is that sort of right livelihood in the sense of doing something with meaning, and not just figuring out how to sell ads. I just they just cannot be meaningful.
You guys know this concept from Stuart Brand, right livelihood? Yeah, he said, if you do something that's really the right thing for you to do, the living will follow, the money will follow.
Are there any final burning questions before? Well, I mean, you probably don't have to leave right this second, but we're officially at the end, so get them in fast.
So every Tesla owner that I've met is a really strong proponent on the car. They all love them. I love mine. Do you see them going in the right trajectory from leaving 18650 cells and making their own and doing all this vertical integration in their factory in Nevada, and kind of going on this crazy way towards integration and manufacturing that isn't traditionally done?
The auto industry has gone back and forth with us. I mean, Henry Ford was big on vertical integration too. Whether Tesla has done the right thing or not is, I think, somewhat debatable. That if there is some big technology change that comes along in the batteries, it may be that they built a white elephant. It's possible. Yeah. I think that there's good arguments to be made on both sides of that one. I can see why they did it. I'm a little more skeptical about the acquisition of Solar City, for example.
I will say I have met and gotten to spend some time over the years, not recently, but long ago, with Bill Ford, the chairman of Ford. And when this idea of vertical integration versus the sort of outsourcing everything came up, He goes, you know, my grandfather was really into that vertical integration stuff. It worked out fine for him. So I thought, wow, he's talking about actually Henry Ford. I mean, like the real guy, or great grandfather, whatever it was. It was very funny. So it's worked out for sometimes it works out.
So it's hard to say. I don't know. I mean, it's a gamble.
Yeah.
I guess a follow-up question: what is it a good move for further efficiencies in electric vehicles? Like right now, my car is around like 300, 400 watt hours per mile. Will that go down?
I don't think it's going to change much.
Okay.
Because, I mean, if you think about the motor, we're already talking about plus or minus 90% efficiency, so there's not a lot of room to improve there. The battery is 93% efficient. It's not a lot of room to improve.
There's no doubling there.
The coefficient of drag on that vehicle is among the lowest of any car made. It's a big car, so CD times A is still kind of big. You can do better by making the car smaller. The rolling resistance is pretty good. So there's, I think that you're not going to get below, let's say, 200 watt hours per mile in a car. It's just not happening, unless the car only moves very slowly. And so you're not going to see big efficiencies there. What you'll see is more range by better batteries. So that's kind of the way I see it.
Yeah.
One last ultra-burning question, if anybody has. Okay.
This is a question on policy. So I worked on a project a couple years back with the California Governor's Office, and he had wanted to put 1.5 million electric vehicles on the road by 2025. And I'm just wondering, since Tesla has now grown so much in the recent years and now has a lot of political weight, is there any kind of concerted policy push to get more policies like that, and maybe not just at the state level, at the federal level, anything like that?
So there's push on both sides of that, right? There's push from the electric car manufacturers, and there's push from the gasoline car makers in the other direction. But in my opinion, I think it in a way doesn't matter. 2025 is actually after my magical crossover date. I think that's going to happen just because you get better cars for less money. It's the technology drive that matters more than anything else. I mean, the key thing that Tesla Motors did, not making one particular model car or another car, but Tesla Motors completely, totally changed the whole world's mind about what an electric car can do and what to expect out of them. Went from thinking that they're dead and they suck to thinking that, of course, the future is electric cars. And by the way, those electric cars are pretty darn nice. Maybe I can't afford that one. But when we started Tesla, not one single car company had any electric car programs. None. Today, they all do. And some of them are pretty good. It's no question about it that the Chevy Volt and then the Chevy Bolt are directly the result of what Tesla's done. Same thing with the Nissan Leaf. Same thing with every other electric car out there.
Okay. And the electric car driving experience is better, I think. And one of the
those of you who drive them know.
Yeah, one of the reasons why Tesla owners tend to be kind of fanatics about them isn't so much about the styling or the customer experience. It's really that when you drive one,
and it's sure not the cup holders.
Yeah, it drives better than any gasoline car that you've ever had, and so.
Vehicles, so I'm just wondering if there's
in the end, it's the money, right? When I can build that car for cheaper, if you can go out there and buy a Toyota Camry or whatever the electric car equivalent is, and the electric car is not only a better car, but it's cheaper, why would you buy the Camry?
Yeah, well, and the other thing is that there will be, at some point, there'll be carbon pricing of some kind, I suspect, in most economies. Because when those kind of external costs actually come down onto the carbon fuels, the economics really get incredibly. But one of the questions that we didn't get to had to do with subsidies and stuff for the electric car industry, and the carbon fuel industry has enormous subsidies. I mean, depending on how you calculate, if you talk to the people who are saying, oh, there's not very much, it's only $20 billion a year in the U.S., and if you talk to the people who say it's a lot more than that, and that's not counting any kind of external costs,
like the military,
like the military keeping our sea lanes open in the Middle East, or even any kind of global warming effects. So, I think that the economics is going to become both as a personal just driving around, they're much more fun to drive, and there's going to be and as they get cheaper, the economics becomes like such a better thing, but because it's no compromise really. And then I think ultimately when carbon pricing comes in, it'll just be. People will think back and go, wow, we had all these very mechanically complicated devices running around burning fossil fuels. That's so crazy.
But there's also, I mean, people always have this idea that whatever the cost of oil is doing now, it's going to do that forevermore. We used to think that we're now in the world of $100 barrel oil, and that's the future forever. Yeah. And now we're saying, $20 a barrel, that'll last forever. And we always say that. And of course, a large amount of the world's oil production comes from unstable places in the world, and it takes who knows what kind of behavior by whoever for that oil pipeline to be restricted, and the price of oil will go back up again, and everybody will think, damn, I shouldn't have bought that Hummer after all.
Thank you so much for coming and speaking to us today.